Hi everyone, and welcome to today's video. I believe that by now we have a firm grip or a firm understanding of most of the basic concepts in trigonometry. We've actually set a good foundation for everything. So today we're going to be looking at some further topics in trigonometry. We're going to be doing some revision so that we have a firm grip and a more perfect understanding of trigonometry. So without wasting time, let's get into today's video. Alright, so let's get into today's video. So we're going to look at trigonometric identities connecting angles of a triangle. Alright, so in this section we shall look at trigonometric identities that connect angles of a triangle. For example, let's imagine the angles were A, B, and C. Remember, a triangle has three angles, so we're going to label them A, B, and C. So we know that it's a rule that the sum of the angles of a triangle total to 180 degrees. So that's a general rule. So the trigonometric proofs in this section will test your knowledge of all we have learned so far. So these proofs in this section will seem a little bit longer and a little bit more complex than the ones before, but they are going to teach you and we're going to apply everything we've done before as a foundation. But I generally want to encourage that it will actually be easy as I show them to you. So let's look at different questions. So question number one: if A, B, and C are angles of a triangle, prove that cos A plus cos B plus cos C minus 1 is equal to 4 sin A over 2, sin B over 2, and sin C over 2. So this is going to be the solution. So we're going to solve from the left hand side towards the right hand side. So let's deal with the left hand side. So we have this cos A plus cos B plus cos C minus 1 is equal to 1. So first thing I see when I look at this is I see that I can apply factor formula for these two first. So that's going to be my first step. So I'm going to apply factor formula there, and then when I apply factor formula there, so this will become 2 cos A plus B over 2 cos A minus B over 2. So factor formula brings out that. Alright, so the next step shall be that now we're going to remind ourselves of the rules from the angles of a triangle. So we're going to make some changes. So we're going to convert this into a C. So this is going to be the first one that we shall deal with here. So you know from angles of a triangle that A plus B plus C is equal to 180 degrees. So if we make A plus B the subject, we have A plus B being equal to 180 degrees minus C. So that's where we go. So we're going to substitute this value here back there. Alright, so therefore we have 2 cos 180 degrees minus C over 2 cos A minus B over 2 plus cos C minus 1. Alright, so we can now so this 2 is going to divide both of these to bring out individual fractions. So here we'll have 180 divided by 2 is 90, and here we'll have C over 2. So that's what we end up having. Now this reminds me of compound angles, and we're going to expand this as a compound angle. So when you expand that, we end up with this expansion. And now when we press in our calculator, cos of 90 is 0, so whatever value is here disappears, and sine of 90 is so sine of 90, when you press that in the calculator, I believe that is 1. Yes, sine of 90 is 1, so we remain with sine C over 2. So this is what we remain with. Now we can see that we've actually proven one side of the equation. So we now have a sine C over 2, which is actually we have this in our final proof. So we're going to leave this as it is. So we've dealt with this. So next step is we're going to deal with this C here. So just make sure to remember the steps that I'm following. So this is dealt with. So now we're going to deal with this value here. Now we remember that from half angles, because this is actually a half angle. Cos C is a half angle. So cos C can be represented as 1 minus 2 sine squared C over 2. Now there are very many ways of representing this. This can also be represented as cos squared C over 2 minus sine squared C over 2. It can also be represented as 2 cos squared C over 2 minus 1. But the reason we use this one, the reason we use the 1 minus 2 sine squared C over 2 is because we want something that resonates or that is similar to this one here. So that's why we convert it into this form. So when we substitute that back into our equation, so we're going to place this where we have the cos C, we end up with that. And as we can see, we can already see that these ones will cancel. So when the ones cancel, this is what we remain with. And then next, you can see that we can factorize out 2 sine c over 2. So you can pull 2 sine c over 2 out of the brackets. All right, so next we're left with these items inside the bracket. So the next step shall be to so we actually want to apply a factor formula again, but for that to happen, we're going to now convert the c to have an a and a b in it, so that we use it as a factor formula with this one. So how do we do that? So again, from angles of a triangle, we know that a plus b plus c is equal to 180. So when we make c the subject, we have c being 180 degrees minus bracket a plus b. So substituting the value of c back, we actually now have this. Okay, so now we can divide the 2 on both sides, and we'll end up with that. So we end up with 90 here, and then this remains as a plus b over 2. All right, so now applying the rules of compound angles here again, we end up with that. So this expands to that value, but also remember that cos of 90 is again 0, so this part disappears. So sine of 90 is 1, so we're going to be left with cos a plus b over 2. So this is what we end up with. Now that we have these looking similar, we can now apply factor formula again. So a factor formula for a cos minus cos. So applying factor formula for cos a minus cos b, so this format of factor formula, we end up with that. So a cos minus cos gives a negative 2 sine sine. So this is what we end up with. So we have this plus this. So that's why we have the values here, a minus b plus a plus b. So this, on this side, they total together. But remember that each one of these already has a 2 as a fraction under them. And yet, we also have a 2 under, in the formula, it also comes with a 2 because it's p plus q over 2, but there's already a 2 here, so that 2 is going to multiply the other 2, and that's why we have a 4. So we end up with that. So now on this other side, we also have this value minus this value, which gives us which will have negative of which will have a negative 2b over 2. When you divide that by the 2 that comes with the formula, we have a 4 under that. So that's what we end up with. So all this becomes this. So we can actually say that this can reduce. So we can reduce these items, and we end up with that. But now remember, when there is a negative sign, and then there is a sign here, this negative will affect this value here. So here we consider the negative. So we're going to pull out this negative, and it's going to affect this negative, and then we'll end up with a positive. So when we pull out that negative, we end up with that. So that negative cancels with this negative. So this is what we remain with. And then when we multiply the items in this bracket with this item, we come up with that. And hence we've been able to prove our equation. All right, let's move on to the second example. So the second example is slightly different. The second example has more of double angles from this left-hand side, but it's still going to be easy. All right, let's solve this. So from the left-hand side, we have this value. Now we are going to apply factor formula to this side again. So it's going to be almost the same procedure as the former one. So applying the factor formula to that, we have this. So we end up with this value. Now it becomes 2 sine cos. All right, so now when we so we can see that the 2's will all cancel, and we'll end up with this. The 2's here will also cancel and end up with that. So we actually have some bit of that. All right, so next step is we're going to deal with this part here. But how do we do? We're going to first look at angles of a triangle. So from angles of a triangle, we know that a plus b plus c is 180. Now a plus b is going to be equal to 180 degrees minus c. So therefore, that means that when we substitute 180 degrees here minus c into this, we end up with that. Then we can also expand this bracket using the knowledge of compound angles. Expands as that. Now we know that sine 180 is 0, so this part disappears, and cos 180 is negative 1, so that negative 1 times this negative changes this to a positive. So we remain with 2 sine c. Alright, so this is what our equation becomes. So now we can deal with, so this side is proved because we have this in our final proof. So now we can deal with this side. So we know from double angles that sine 2c is 2 sine c cos c. So when we substitute that into the equation, we end up with that. Now we can see that we can actually pull out 2 sine c from both sides. So we can factorize out 2 sine c, and this is what we remain with. Now next step is now again to convert this c into a plus b, so that we actually have a formula where we can do factor formula together with this value here. So again, from angles of a triangle, we know that a plus b plus c is 180. So c is equal to 180 degrees minus a plus b. So when we substitute that in, we end up with that. Now applying compound angles here, the knowledge of compound angles, so it expands to that. So we also remember that cos of 180 is again a negative 1, and sine of 180 is 0. So we end up with a negative in front of cos a plus b, which means that there will be a subtraction sign. So now applying factor formula to both of these, so we know that when you have a cos subtracting a cos, we end up with a negative 2 sine. So we end up with that. So we have this value here adding this over 2, and then we have this value subtracting this value over 2, just like that. So now we come up with answers. So we end up with 2a for this side, then we have negative 2b for this side. But now because we have a sign here, this negative will multiply this negative, and we'll end up with that. So actually these 2's first cancel, then you end up with that. So this negative affects this negative, and then we end up with that. So hence we've proved that that it is equal to 4 sine a sine b sine c. As easy as that. All right, let's move to the next one. All right, if a, b, and c are angles of a triangle, prove that cos 4a minus cos 4b minus cos 4c is equal to negative 4 sine 2a sine 2c cos 2b minus 1. So let's prove from the left hand side. So from the left hand side we have that. So we're going to apply factor formula to this side. So applying factor formula there, we end up with, so factor formula to that, we end up with that. So we have negative 2 sine 4a plus 4b over 2 sine 4a minus 4b over 2 minus 4 cos 4c. Now as you can see here that this will reduce to that, so we end up with this value. All right, so now next we know from angles of a triangle, so now let's deal with this side. From angles of a triangle we know that a plus b plus c is equal to 180. Now the difference here is we have 2a plus 2b. So let's convert these to look almost similar. So we do that by multiplying a 2 on both sides of the equal sign. Then we end up with that. So we end up having 2a plus 2b plus 2c is equal to 360 degrees. Now making 2a 2b the subject, we end up with 2a plus 2b being equal to 360 degrees minus 2c. So now we can substitute this value there. So therefore that becomes that, and then when we expand this by rules of compound angles, we end up with that. Now sine of 360 is 0, so this disappears, but the cos of 360 is positive 1, so that means this negative remains. So we end up remaining with negative sine 2c, and when we multiply that by the 2, we have negative 2 sine 2c. So this is what we end up with. So now we have part of the proof appearing. Now the next step shall be to convert this cos 4c. So now from rules of double angles, we know that cos 4c is the same as cos 2c plus 2c. Then when you expand that, we end up with cos squared 2c minus sine squared 2c. So now we need it to be in a format where we only remain with the sine. So we're going to convert this cos squared to be a sine squared. So when you convert that, we end up with 1 minus 2 sine squared 2c. So now we can substitute this back there where we have the cos 4c. Then this is what it becomes. All right, when we open those brackets, we end up with negative 1 plus 2 sine squared 2c. All right, so we're going to collect this like term. We're going to bring this closer to that, and then we'll end up with that. So when you bring this closer, taking the negative, the minus 1 to the other side, now we can pull out of brackets. So we can factorize out the 2 sine 2c, and then inside the bracket will remain with negative sine 2a minus 2b plus sine 2c. So now next step is we now want to convert this 2c in a format where we can actually work with factor formula compared to this one. So now again, from angles of a triangle, we know that a plus b plus c is equal to 180. When you convert that into this format, we end up with that. So making 2c the subject, we know that 2c is 360 degrees minus bracket 2a plus 2b. So therefore we know that we now have this. So substituting this where we have 2c, this is what it becomes. Now applying the rules of compound angles here, so this expands to that, of which we know that sine of 360 is 0, so this disappears, and cos of 360 is positive 1. So we end up having negative sine 2a 2b. So this is what we end up with. So now I've seen something we can do. We can pull out the negative out of the brackets so that we remain with positives inside, and then we will have that. So now we're going to apply a factor formula to this part. So applying the factor formula for where we have sine plus sine, we know that applying factor formula we end up with that. So this becomes 2 sine cos. So now these values plus these values over 2, then these values minus these values over 2. So that's what we end up with. Alright, so we have a 4a up and then we have a negative 4b there. So this reduce to become that. So we have it that way. But now we have a negative 2b here. Now when it comes to cos, when you have a cos here, we ignore the negative sign every time there is a cos in front of it. So this negative 1 is meaningless. And I've said that is because a cos of an angle is always positive, irrespective of the negative sign. Alright, so now this becomes negative 4 sine 2a sine 2b cos 2b minus 1 because of the negative 1 minus 1 that we have on the other side, and hence we've proved our equation. Alright, let's move on to the next one. So if we have a, b, and c are angles of a triangle, prove that it becomes that cos 4a plus cos 4b plus cos 4c plus 1 is equal to 4 cos 2a cos 2b cos 2c. So let's prove it from the left hand side. From the left hand side we have that. So now we're going to apply factor formula to this. So applying factor formula there, we end up with that. So we have it becoming 2 cos cos. Okay, so this becomes that because the 2's and the 4's will reduce to that. Alright, so now next we know that now let's convert this. So we know from angles of a triangle, we know that a plus b plus c is 180 degrees. So I'm going to multiply a 2 on both sides so that we have something that looks similar. So we know that now 2a plus 2b is 360 degrees minus 2c. So when you substitute that into the equation, substituting this back in, we have that. So now applying rules of compound angles to this side, we end up with that. But now cos of 360 is positive 1, but sine of 360 is 0. So this disappears and then remain with a positive 1. So this becomes 2 cos 2c. Alright, so now after this we can now deal with this side. So we know that again from double angles, we know that cos 4c becomes that. So next one it becomes that. But now for this case we are dealing with so when you look at this side, we have a 2 cos 2c here. So now we want to convert this in a format where we retain the cos 2c. So now we're going to change this to have a cos squared 2c. So when we change that, we know that it becomes that. Alright, so therefore this becomes this, as you can see. And now we can easily, so you know that there is a minus 1 here, and now this minus 1 plus this 1 that was already in existence, they all cancel, and then we remain with that. And now this becomes simpler to work with because we can now simply factorize out 2 cos 2c. So when you factorize that out of brackets, we remain with that. Okay, now this is a bracket there. Alright, so now we're going to convert this to have a double, to have an 2a plus 2b inside. So how do we convert that? We also know that from angles of a triangle that we have that. Now 2c is the same as 360 degrees minus 2a plus 2b. So therefore, when we substitute that back in where we have the cos 2c, we can see that we will have this expansion. Okay, so now applying the rules of double angles here, we can say that expands to that. And then cos of 360 is positive 1, but sine of 360 is 0. So this part cancels, disappears. And now we end up remaining with cos 2a plus 2 B. So this becomes that. So now we're going to apply factor formula to this side here, and then when you apply factor formula we end up with that. So it expands to this, and now when we simplify that we end up with that, and now this 4 and 2 reduce, and then when they reduce we end up with that. But now this is again another example where there is a cos of a negative angle. Now the cos of a negative angle is always a positive, so we're going to ignore this negative sign, and then we'll end up with that, and hence we've proved our equation. Alright, let's move on to the next one. Now we're given a unique one. We're being asked if A, B, and C are angles of a triangle. Prove that tan A plus tan B plus tan C is equal to tan A, tan B, tan C. So it's a product of tan A, tan B, tan C. Alright, so let's solve this from the left hand side. So from the left hand side we have that. Now this is gonna be easy to solve, but we will have to remember double angles. So here we're not going to use factor formula, we're going to remember double angles. So from double angles, remember that tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So now if we make tan A plus tan B the subject, we end up with that. Now the reason we make tan A plus tan B the subject is because we can easily substitute its values into our initial equation. So therefore our equation becomes that. Alright, so now next we know that from the angles of a triangle that A plus B plus C is equal to 180. That means A plus B will be 180 degrees minus C. So when we substitute that into our equation where there is A plus B, we end up with that. But now from the rules of double angles, we know that when we expand this value, tan 180 degrees minus C, it becomes that. So it becomes tan 180 degrees minus tan C over 1 plus tan 180 degrees tan C. But when we press on our calculator, we know tan of 180 is 0. So we can already see that 0 times tan C is 0, and 0 plus 1 is 1. So we have 1 on the denominator. Then at the top we have 0 minus tan C. So at the end of it all we remain with a negative tan C on this side. So now when we open brackets here, we can see that we end up with that. So it becomes negative tan C plus tan A, tan B, tan C plus tan C. So now this and this will cancel, and then we'll end up with that. And hence we've proved our equation. Alright, so let's move on to the next one. So if A, B, and C are angles of a triangle, prove that sine A plus sine B, sine bracket B minus C is equal to 2 sine B cos C. So let's solve this from the left hand side. Now I think the first step we can already see is we need to find a way of converting this A so that it has a B and C in it. How do you do that? From angles of a triangle, A plus B plus C is equal to 180 degrees. So now A is the same as 180 degrees minus B bracket B plus C. So therefore when we substitute that back, we have that. So now when we expand this using the knowledge of compound angles, we end up with that. But sine of 180 is 0, so all this cancels, and cos of 180 is negative 1. So negative 1 times a negative is positive. So we remain with sine B plus C. Now that we have this, we can simply apply factor formula. So applying factor formula to that, we end up with this. So we have B plus C plus B minus C over 2. Then we have B plus C minus B plus C over 2. Now when we are subtracting, that negative will affect these, then that's why we end up with that. Okay, so when we simplify this, we have 2B from here, then we have 2C from here, dividing by 2, so these 2's cancel and we end up with that. So we've actually ended up proving our equation, as simple as that. Alright, so lastly I have some trial questions for you. So these are extra proofs that you can actually try out in your free time to get better at this section. So prove the following identities: A, B, and C are to be taken as angles of a triangle. So this is number 1, then this is going to be your number 2, number 3, number 4, number 5, number 6, 7, and 8. I believe once you've tried these out and perfected them, you'll be a pro or a prodigy, I would say, in this section. Thank you for watching. Trigonometry. If this video really helped you, feel free to leave a like on the video and feel free to leave a comment to tell me if it was really helpful to you. And then if you're new to this channel, I still remind you to subscribe and then make sure to hit the notification bell so that you get updated every single time I upload a new video. See you all in my next video.